I'd like to consider the discussion that we had in the previous video, previous two videos actually, and kind of put them together. So I'm going to consider the example of, again, remember the examples were the black text. I lift the box up like this, and I've reminded you of all the different types of energy that we looked at in that video. The kinetic energy doesn't change, but the potential energy and the total energy do. And the other case was I drop it, in which case the kinetic energy changes, the potential energy changes, but the total energy doesn't. And let me consider the work done in each one of these cases. Okay, I'm actually going to start on the right. I think the red one is a little bit easier to understand, so let me start there. In this case, so first of all, you can see that the potential energy changes. The potential energy goes down. So if I use principle number 3 up above, I can say that there was internal work done here. And the internal work done is negative 0 minus mgh, because remember it's negative final minus initial, or initial minus final if you prefer. It's the same thing. So then this gives you a positive internal work done. Okay, so the work done on the system is positive. What is that saying? This represents the work done by gravity during this process. And how do I know that? Is that I used the gravitational potential energy to calculate that. And since I used the gravitational potential energy there, I know that the work I'm calculating is the work done specifically by gravity. Okay, now, in this case, gravity is the only force that's doing work on the system. Gravity is the only thing doing work on the system. I have just calculated the work done by gravity. So I can also say that the total work done on the system is going to be the same as the work done by gravity because it's the only thing doing work here. And that's going to be delta K by principle number 1 up above. The total work done on the system is equal to the change in kinetic energy. So I'm using that now. And I get the result that the change in kinetic energy is equal to mgh. And notice the change in kinetic energy is also equal to half mv squared. So we end up with half mv squared equals mgh, which is the conservation of energy equation. So everything checks out. Notice that the 3 statements are consistent with each other. Number 1, the total work done on the system is half mv squared, but it's also mgh because there's only one thing doing work on the system. Number 2, the external work done on the system is 0. I'm kind of out of space here, but I'll write it up here. The external work done on the system is 0 because there's no forces from outside the system doing work. So there's no change in the total energy of the system. So we end up getting that the total energy change in the system is 0. The change in the gravitational potential energy is minus mgh. The change in the kinetic energy is plus mgh. And everything makes perfect sense. That's what happens in a conservation of energy type problem. All that happens is the kinetic goes up, the potential goes down by the same amount, the total energy remains the same. So in the work framework, what we would say there is that gravity did positive work on the system and energy was transferred from the gravitational potential energy into the kinetic energy. And that's my summary of the red case. Okay, let me just get rid of this to make a little bit of room. Now let me switch over to the black problem. Now, the black problem where I described the object starts like this and I lift it up and the ending state is like this. This is a problem which confused me so much when I was a student because it seems like it contradicts what my teacher is telling me, because my teacher is telling me that work equals change in kinetic energy. But look, here there's no change in kinetic energy. So does that not imply that there's no work done? Well, in a sense, yes, but you have to be careful what you mean by that. The total work done on the system has to be 0 here. the total work done on the system. How can that be? Well, let me just keep going here. If I look at the potential energy, I'm going to see that the internal work done by gravity is going to be negative final minus initial. So that's negative mgh, okay? Gravity did negative work on the box. Gravity did negative work on the box. How does that make any sense? Well, that's because gravity is actually pushing the object downward, but I lifted it upwards. So gravity was actually, you know, kind of failing to do work on the system, or gravity was actually, to put it another way, gravity was actually absorbing energy from the system because it was storing that energy as potential energy. That's what negative work done on a system really means, is that it's actually absorbing energy and stealing energy from the system and putting it somewhere else. In this case, gravity is taking energy away from the box and storing it as gravitational potential energy. Okay. Then the change in total energy of the system is external work. So the external work is going to be mgh minus 0. And where is this external work coming from? Well, that's coming from me. I am an agent external to the system. You are not keeping track of my potential energy or anything like that. So I'm kind of a wild card here, where I'm not being included in the equations in a direct way. So that's why there's external work being done on the system, because I am putting an extra mgh of energy into the system. And now maybe you can start to see what's going on. What's happening here is there are actually two things doing work on the system. The total work done on the system is the work done by gravity plus the work done by me. And the work done by gravity is minus mgh. The work done by me is plus mgh. And sure enough, that sums to 0, just like the textbook said it would. So in this case, the total work done on the system is 0. So the change in kinetic energy is 0. But that's because there's negative work being done by gravity, positive work being done by me. And what that means conceptually is that I am putting energy into the box, but that energy is immediately being transferred into gravitational potential energy. So effectively, you know, this is like in my bank account analogy. This is like I'm trying to deposit money into the checking account, but as fast as I'm depositing into the checking account, you keep on transferring it over to the savings account. So effectively, at the end of the day, even though you got paid, your checking account balance didn't change because you transferred it directly out of the checking account as soon as it was transferred in. So the change in kinetic energy was 0, but my energy that I put into the system ended up going into the savings account. And all of that is also consistent with each other. So you can use oftentimes various combinations of these 3 ideas above to understand different problems. And you can often use several different combinations to even understand the same problem. But the first step is to understand the thought process behind this so that you can actually wrap your head around it. Because if you try to just use the formula of work energy theorem, that's where you run into trouble, because a lot of times, if you don't understand what you're doing, it seems like work energy theorem doesn't work. But that's because you're probably not considering all the different types of energy that are important.